In this example, we're going to look at how to calculate slope if our terrain type was a raster. So in this example, we want to know what is the slope between points A and B. So we have a raster grid, and each of our grid cells are going to be 2 meters by 2 meters, and we have some values in each of our grid cells. So each of these values represent an elevation value. So our upper left is an elevation of 344. The right one is an elevation of 337. We have elevation of 335 and elevation of 343 over here on the lower right. We have a point A and we have a point B. And we're wanting to know what is the slope between these 2 points. So I kind of drew a line right here. So step 0, I'm going to study the given, which we've been doing here. We notice that we are kind of missing 2 of our variables, but sort of not. They're just not directly given to us. We're going to have to do some math in order to figure out a couple of variables. So we're wanting to know the slopes. Obviously that's the unknown, but we need a couple of given information, and that is our change in the elevation and our change kind of in the XY plane here. But we don't have that directly given to us, but we can definitely derive that. So step 1, need to draw a diagram. So our slope is our unknown, and we need to figure out our change in the z, or the change in the elevation. And to do that, we need to take the high point minus the low point, just as we did before. So in this case, the elevation at point A minus the elevation at point B. So I'm going to draw a section here. So there's our point A and B. There's our line. So this is where I took my section cut. So that represents our change in z. And to figure that out, we're just going to take 344 minus 343. So the 344 is obviously our high point, and 343 is our low point. And when we subtract those two, we get the value of 1. Now we need to figure out what our change in x is. So I'm going to draw a plan view. So there's our point A and B in plan view. There's our line, or slope line, that's running across there. So that represents our, I'm going to call it the change in x, but what it really is the change in the xy plane. So one thing that I recognize right away is that I have a right triangle, meaning that I could likely use Pythagorean's theorem. So we have sides A and side B here, and we can use this equation, which is the Pythagorean equation. And now I'm just going to rearrange it a little bit and kind of use my own variables for wanting to find the change in x right here. So we see that right here. This is our A and this is our B. So what values should go into A and B? So what I've written here is the value of 2. And the reason why is because our grid size is exactly 2 meters. So if this is exactly halfway across cell 344, so this is 1 meter to 1 meter here. So this is 1 meter to here, and then it's another 1 meter to here. And same thing with here, since this is exactly halfway point, we have another 1 meter and another 1 meter. So this length from here to here, I know it's not drawn exactly at center, but use our imagination. From here to here, this value here, which is along the A length, would be 2 meters. The same thing with the B, since this is a perfect square, meaning that each of these angles here, the angle at A and the angle at B, is going to be 45 degrees. So we take the square root of 2 squared plus 2 squared, which is going to give us the value of square root of 8, which represents this slope, this not slope value, but the c, this length here in our Pythagorean theorem triangle. Step 2, we set up our equation. We're going to use our slope equation. Step 3, we plug in and solve. So we take 1, which is the change in the elevation, divided by the change in the xy plane. So that's going to be square root of 8 times 100, which is going to give us our slope, and the answer is 35%.